We're going to talk about properties of exponents. The first property is called the product rule. The product rule, which states x to the m times x to the n. If the bases are the same, we can add the exponents. Bases have to be the same. So here is a proof using actual values. So we have x to the third times x to the second. The definition of the exponents means x to the third. That just means we have x times x times x. 3x's being multiplied together. Times, we have 2 x's, x times x. Using the definition of exponents again, we have 5 x's being multiplied together. We can write it as base x to the 5th power. Or, as you can see, we could have just simply added the powers together. We have the quotient rule, which states x to the m over x to the n. When you divide, we take the powers and subtract them. So the proof, x to the 7th over x to the 5th, if we write these out, and we know x divided by x is 1, so these cancel out, and we are left with x to the 2nd, or x to the 7 minus 5. The power rule is next. Power rule states we have x to the m to the nth power. Well, we go x times x to the m times n. So when you raise a power to a power, you get mightier, you multiply. So power to a power, it's like you're adding more power to your term, and to get more power, well, you multiply. The other power the other power rule is if you have x y to the m, you can say, well, that's x to the m, y to the m. And then x over y to the mth, that's x to the m, y to the m. You can only more or less distribute this m through, or the power through, if you have multiplication or division. If you are bound by addition or subtraction, meaning that this is x minus y or x plus y to the mth power, you cannot distribute that. If you have division or multiplication, you can go ahead and distribute. So I'm going to show a proof on these two. This one would be similar to this one. So for this first one, if we have x to the 2nd to the 3rd power, well, this means we're going to have x to the 2nd times x to the 2nd times x to the 2nd. Well, that means we have x to the 6th power, or x to the 2 times 3. The second one, we have y to the, let's say, 5th power. So that means we have xy times xy times xy times xy 5 times. So then that means if we combine like terms, we have 5 x's and we have 5 y's. Similar proof to the division. The zero exponent rule states that if you have x to the 0 power, it equals 1. This does not mean x can equal 0. So 0 to the 0 power just is not 1. you can't do it. So a couple proofs here. If you have x to the m power over x to the m power, and you go back to the quotient rule, that's x to the m minus m, that's x to the 0, or they cancel out, leaving us with 1. The other proof I would like to show you, and you can do this with any number. If we have 2 to the third, that's 8, 2 to the second, that's 4, 2 to the first, that's 2, 2 to the 0 power, well, each time we stepped down, we divided by 2. Even on this side, we divided by 2. So 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2, well, that's 1. You can do the same with the 3's. 3 to the third power is 27, and you'll have 9, 3, and then 1. Then we'll have negative exponents. If you have a negative exponent, that's x to the negative n, you can have x, or 1 over x to the n. Same thing, if you have x to the negative nth downstairs, you can bring it upstairs. And the last one, if you have a fraction to the nth power, you can flip that upside down and make the exponent positive. So anytime you have a negative exponent value, you can take it, ship it downstairs or upstairs to make the exponent positive. So some examples here. So y to the third, y to the fourth, y to the third times y to the fourth, add the exponents 4, 5, 6, 7. And then we have x to the second, y to the third, x to the third, y to the fourth. If we combine like terms, we have x to the fifth, y to the 4, 5, 6, 7. When you have various properties to work with, what we need to do is simplify the numerators and then the denominators, then combine. Ignore this value out here. You're going to do that at the very end, so you're not flipping things around all the time. So the 2 stays because we can't simplify it. We have x to the fourth, x to the second, 4, 5, 6. That would be 6. And then we have y to the third over xy to the fourth, all to the negative 2 power. Then let's see here. Next, we can go across the division. So we have 6 minus 1. Remember, anything without a power is always to the power of 1. 6 minus 1 is 5, so it goes upstairs. Y to the third over y to the fourth. 3 minus 4 is negative 1, but there's a trick you can do. Just take 4 minus 3, which is 1, wherever you're heaviest at, either the top or the bottom, numerator or denominator. For instance, where 4 is bigger than 3, so we're bottom heavy, we will place that value in that spot. So we'll place it in the denominator. And for instance here, x to the sixth was bigger than x to the first. We placed our value in the numerator since 6 was bigger than 1. We were top heavy here. And then we can distribute the power, the negative power. And actually we could have flipped it and then distributed it, but that's okay. Since we have x to the since we have 2 to the negative second power, we can bring it downstairs and turn it positive. X to 5 times negative 2, that's negative 10. So we'll have x to the negative 10. That can go downstairs to make it positive. And then y to the negative second, we can move it upstairs to make it positive. We still need to evaluate x, or excuse me, 2 squared, which is 4. Okay, so make sure you see yourself through, make sure it's all evaluated. Now, I have seen many mistakes involving what to move when we are dealing with negative values. This -4 is only applied to the x. This -3 is only applied to the y. 5 is not affected by a negative exponent. It doesn't even have an exponent, or you can think of it as an exponent of 1. Z is affected by the -2. So all we have to do is organize. 5 stays because it doesn't have an exponent. But we can take z to the -2 upstairs to make it +2, x to the 4th downstairs, and y to the 3rd downstairs. Okay, let's look at this one. We have -2 times x to the 3rd, y to the -1st. We can distribute that value, that exponent, to each of these terms, which in this case you would not have to write all that out. You would just put a 6 in the -2, but I'm just trying to be thorough. -2 squared will be +4. We'll have x to the 6th, y to the -2nd. This is not complete yet. We cannot have a negative value if we're trying to simplify. So what we're going to do is only take that y to the -2nd and bring it downstairs to make it positive. This concludes our video.